Well, hello everyone, and welcome to the April 2025 edition of the St. Louis Java Users Group. Next slide. So for those who don't know, the St. Louis Java Users Group is an informal group. We've been meeting since May of 1997, which makes us one of the older JUGs around. Attendance is free. We have no formal membership list. Normally, we try to meet on the second Thursday of every month except December when there is no meeting. We have no meeting in December because there's just too many things going on over the holidays for us to organize a meeting then. And once in a while, we might move a week earlier or a week later to accommodate a speaker schedule, but we aim for the second Thursday. For those of us who are here in person, you can join us for food and social beginning at 6 p.m. and the meeting starts for everybody at 6:30. This live stream is originating from the Object Computing Incorporated training room, and we're at 12,140 Woodcrest Executive Drive, Suite 310, and of course that's in St. Louis, Missouri. Next slide. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Zach Klein, Ted Doyle, raise your hand, Robert Levitt, there you go, Wei-Chi Gao, and Bruce Allspoil, that's me doing the narration. You can reach all of us on the steering committee at that address at the bottom of your screen that may be hard to see a little bit right now, but it's javasigsc@googlegroups.com. Next slide. The St. Louis Java Users Group would not be possible without the support of our sponsors, so I'd like to thank Object Computing Incorporated. They've been here with us since 1997, since the beginning, and they have filled in and saved our bacon so many times I can't even begin to count. At the end of this meeting, if you want to stay in the room or if you're online, stay online after the presentation, we will be raffling 2 Manning eBooks and 2 JetBrains licenses. And another sponsor I need to thank is Neo4j, because they sponsored the pizza here for those of us in the room tonight. So big thanks out to Neo4j. But I should mention that the JUG is in need of additional sponsors. So if you know a sponsor or you'd like to sponsor, have them email the steering committee at that same address before. That's javasigsc@googlegroups.com. Next slide. One of our sponsors has a 40% off discount code for any of their products at Manning. So when you go through the checkout, you can use that discount code JUG13 to get 40% off any of their ebooks. Next slide. And Jay Zimmerman, who is the organizer of the No Fluff Just Stuff conferences, is putting together his next conference. And that's UberConf 2025 coming up. That'll be at the Westin Hotel, Westminster, in Denver, Colorado. And that'll be July 15th through the 18th. And he's given us a discount code. So if you'd like to go to that, you can get $200 off, Uber 25, JUG 2. And we have early bird pricing on that through May 2nd. But if you want all the details, that's easy. Just go to uberconf.com and we'll have all the details there. All right, next slide. If you'd like to keep up with our presentation schedule, that's easy to do. Just go to our meetup page. That's meetup.com/gatewayjug. And as we get presentations scheduled, we post them on Meetup, and you can RSVP for them so that you'll get a reminder. Also, this live stream is being recorded, and I'm just saving it up to my YouTube channel. So probably in a day or two after the presentation, you'll be able to go to that address, youtube.com/@Bruce Allspoil, my name. Now, if you're interested in giving a presentation or becoming a sponsor, just email the steering committee at that same address I keep on promoting, javasigsc@googlegroups.com. All right, next slide. So enough about me. We're ready to hear from tonight's speaker, Jennifer Reif from Neo4j, on what does GenAI mean for the Java developer. So I'm going to turn off my microphone here and let you take it away.
Okay, sounds like a plan. All righty, and this should all be good, I think. Okay. Ready to go there. There it goes. Okay. Off to the races. That was loud. All right. So tonight we're going to go through just kind of a very quick overview of generative AI and how to get started with that. What are all the kind of the pieces that you need to get rolling with things, and give you hopefully a good foundation to get the ball rolling in your own generative AI development. A little bit of background on me. I'm a developer advocate at Neo4j, have been for the last several years now. And I really just like learning about technology and then sharing what I've learned in a variety of different ways. That includes conferences, meetup events like this one, virtual presentations, and so on. But I also really enjoy tech blogging and now tech podcasting as well. I don't have my podcast mentioned there, but it's all over connections on socials and things too. So I do have hobbies outside of work. Most of those boil down to the fact that I'm kind of a geek in a lot of different ways, and I kind of enjoy it. So if you think of questions later on down the road, past tonight's meetup, weeks, months, so on, feel free to reach out to me on whatever social platform is your preference. I've got a bunch of contacts linked there. I'm more than happy to talk tech, Neo4j, data, and so on. Okay, so if you've even followed some of the space of AI, generative AI, that's been going on the last couple of years, you've probably seen a lot of terms come up. And I remember when this wave really first kicked off at the end of 2022, beginning of 23, it just seemed almost overwhelming, the amount of terms and concepts and acronyms that got tossed out, right? But I like to go back to the basics and just start with a very simple definition to kind of base everything else off of. So generative artificial intelligence, or GenAI, as everybody shortens it to, is artificial intelligence that's capable of generating text, images, or other data using generative models, often in response to prompts. Generative AI models will learn the patterns and the structure of the input training data and then generate new data with similar characteristics. So it's taking input, generating similar things, and giving you output. Kind of like a lot of tech systems we're used to, right? But there is one key difference there, and that is it's similar characteristics. It is probabilistic information that's outputting. And this is where the large language model comes into play. ChatGPT released the end of 2022 in November. That was released by OpenAI. And it is short for Chat Generative Pre-trained Transformer. Very long, complicated term. But basically what it does is it's going to give you a natural language response by predicting the next word of the answer. So you ask it something, you ask it to do something, it will predict the next term in whatever its response is going to be. It uses feedback and reward to rank its responses, and it's used for a variety of different use cases. If you haven't been keeping up, anything from professional to personal to literally anything on the planet, people throw ChatGPT at it, right? But when you start to boil down, is it really worth it? Is it worth me getting involved in this and keeping up with all the latest and greatest stuff, investing my time and my energy in figuring out how to develop with this stuff and incorporate it into my business? There's a few things that it is really, really good at and a few things that it's rather embarrassing at, right? But we have to remember that LLMs give answers based on probabilities. There's no like magic to them, really. They're giving you, for instance, if you're using a text model, they're going to produce a text response that again is probabilistic. It's non-deterministic, which means it's not ones and zeros and true and false. It's kind of, you're going to end up with something slightly different every time. But it is trained on public domain knowledge, basically the internet. It's very good at creativity, things like the arts, and things like human assistance and task delegation. We've seen examples of this crop up throughout the news and business and so on. But there are some issues. First of all, there is a training data cutoff. So it's going to lack anything that's most recent. If you ask it about some latest event or ask it to summarize like all of a particular sports data for the last 3 years, it might not have access to all of that information. It might not be able to summarize that data because it wasn't trained on it. You will get a few cases where it doesn't always produce a completely natural language response. Again, that text response is going to be based on probabilities. You're not always going to get something super clear every time. It doesn't really handle things like language complexities, things like reading between the lines, sarcasm, emotion, things like that. It also does not produce sources for the responses that it gives. So it doesn't usually tell you where it got that information or like provide a whole lot of links for where you can back that data up. And sometimes you'll reach into like edges of the LLM's training, or you'll end up in scenarios where it doesn't quite know the answer, it doesn't know how to go about the task, and this is where it's going to end up hallucinating or kind of just making stuff up. Again, that goes into that probability sector for when it doesn't quite know where to go. It kind of just makes its best guess. It tries to be helpful, but oftentimes then we'll end up with inaccurate responses. And of course, things like intellectual property bias and privacy, they're getting better about these sorts of things, but we haven't solved all the problems there either. Okay, so we found out over the last couple of years, if we've seen anything in the latest news stories and how people are incorporating AI, and some of the chatbots have gotten companies and such in trouble, that simply adding an LLM just doesn't work. We have to go about things a little bit differently when we're talking about generative AI systems. And there are a few different strategies to improve an LLM's accuracy. That you can build your own custom model, but that is super expensive. It takes a lot of money, a lot of resources, a lot of compute, a lot of data, and a lot of expertise. You have to have a lot of very skilled data scientists in order to train your own model, to have it run those probabilities in the algorithms, to refine it, to customize it, and so on. You can do something called fine-tuning or few-shot learning, which is similar but much less resource intensive. So you can provide it some examples, you can tweak the tuning after it gets done being trained, and just provide it some examples and help kind of guide it in some of the things you want it to do. Again, though, this usually requires a lot of data science expertise and some resources in order to kind of add that training on at the end. And then there is the retrieval augmented generation, or RAG. And this is the one that is most popular. It's the one we're going to be talking about most tonight. But all of these solutions that I've mentioned involve tacking on to an existing LLM. They're training an LLM on specific data. The one that is most popular right now, because it is the simplest implementation and the cheapest implementation, is called RAG. And this pulls data from external sources. So when I first came across this term, RAG, retrieval augmented generation, it sounded way complicated and very flowery. And it is. It's very flowery words all put together. But if you break each word down, it is exactly what it says it is. So retrieval is just data retrieved from some external data source. Often that's a database, but it doesn't have to be. It could be a web page, it could be a text doc, it could be a PDF, it could be who knows what else. Most often that's going to be plugged into a database, though, to retrieve data. Then the augmented part, that's going to augment the LLM's response with facts. If you're in the music world, you know augment means to raise or to add to. And so augmenting is you're augmenting the LLM's information with data from this external source. And then the generation piece is what the LLM is actually really good at, which is generating a response, summarizing that information in natural language that we can understand. So you kind of end up with this kind of architecture for your application. You have some kind of input coming from the user. Often that's a question or something you want the LLM to do. And then it's going to go out to an external source, often a database, retrieve relevant documents back to that, send that and the initial prompt over to an LLM, I like how it's a parrot there, over to the LLM in order to basically spit out a response, hopefully that is helpful, right? Okay. Now, what if we want to be able to provide context that we already have? We want to plug it into databases. After all, we have tons of companies and internal knowledge all over the place. Why can't we just plug it into existing resources rather than starting over and building this information from the ground up? And this is the idea of retrieval augmented generation. We take a database or some kind of knowledge store somewhere that we already have good quality data, and we plug it into an LLM to add to it. This information already has good internal value. It already is very high quality. We've curated that information in some type of data structure, right? And we want to be able to plug the LLM into that. Now, the good things about this is that you can kind of help guide the probabilities of the LLM using this context or the data from this external source. It's also going to help focus or narrow the probability area when the LLM is trying to generate its response. Again, it kind of helps guide it into the right area of its knowledge, if you will, to generate the probabilities. It's going to help add to the LLM's knowledge as well. Again, if the LLM has outdated information that's 2, 3, 4 years old, you can add to that by adding recent articles or recent data or something like that. It also can help reduce the margin of error. Again, you're kind of pointing it in the right direction and saying, this is kind of where I want you to look, or this is kind of the information that I want you to look for. And then it can help kind of refine its response a little bit more to what you're looking for. And then it also can help us understand how the LLM got to that answer in the first place, because we can see what data is being sent over to the LLM. We can validate, oh, here's its response, here's the data we sent it. Therefore, I can look at those two things and say, oh, I know where the LLM kind of got this. Now the question becomes, how do I serve this information up to an LLM? Because you can't just plug it into a database. It doesn't understand data structures and databases in general. So there's a couple of steps that we're going to walk through. The first is to kind of create some sort of format that is easily readable and understandable by a lot of different things, right? So some universal format. And then the next thing will be to try to search all that information and then possibly pick a data store or someplace you're going to house that information if you don't already have one. And then get that into the LLM, or add that to the LLM, I should say. So the universal kind of data conversation piece is called vectors. Now, when I first came across vectors, I looked at all the math behind it. I'm not a mathematician. I'm a developer. And so I wanted to understand, how do we actually use vectors in the real world? Now, some of you may make the case, okay, that's not very real world, but okay, bear with me. The first example, though, I want to talk about is this airplane example on the left. I really love this one. How do we actually use vectors in the real world? Well, you use it when you're flying an airplane, for instance. So you have a trajectory, a path that you have for that airplane. And maybe you have an external force, like a wind, that's going to push you off course. Now, if you don't accommodate that wind or those external factors, you're going to not end up on the same original destination you had, right? You're going to end up off course somewhere. Same thing if you had a tower in your way or something like that, you would need to move that trajectory a little bit to accommodate for those things. So this is where you can take, okay, I have my trajectory calculation basically in three-dimensional space because you're in the air, and I have this external force. I can calculate how far off this is going to push me, so I can modify my trajectory to take that into account and still end up at the destination where I wanted to be in the first place. So you can make those calculations because we can kind of lay a point or a path, a line in direction, which is what a vector is, and accommodate for those forces. Now, the thing that I like about this Star Trek reference is, even though we don't currently have this, we'll see what happens in the future. We don't currently have this. The thing that I love about this is it's multi-dimensional space, which is what vectors deal with. Vectors are way more than three-dimensional, up, down, gravity forces at work and all that sort of stuff. Multi-dimensional space is much more like outer space. But you also have a lot more obstacles potentially in your way, right? If a starship wanted to end up in a particular point, the air, there's a lot fewer obstacles typically. But in space, you could have planets, you could have black holes, you could have asteroid belts. And those are basically features along your vector that you would want to take into account and maybe modify your vector, your path, your trajectory in order to go around those things. So you wouldn't go through a black hole, or you wouldn't end up in the middle of a planet when you materialized. So you would need to take all those things into account, those features along that trajectory, and then modify it accordingly to where you want it to go. Okay, now what Google did with this is they took vector representations or numerical representations and applied it to words. So I think this was a paper that was done several years ago now. But let's say, as an example, you have the numeric representation for king, numeric representation for man, numeric representation for woman. And if you take the vector representation for king, subtract man, add woman, you're probably going to get a new vector representation that's either the same or very similar to queen, right? The way that we understand and use the term king in language, ruler, lives in a castle, has a lot of wealth, makes big decisions, and so on, very similar. The biggest difference between king and queen is mostly the gender, right? But what I find really cool about this is that now we can take concepts that we understand very well and relate them maybe to new concepts that we don't understand very well, because we can see how similar, how close these two things are related, because we can calculate them down to a numeric representation. Now, what I find kind of funny too is you always have people that for years said, oh, you can't compare apples and oranges. Those are apples and oranges, you can't compare them. Well, now if you can create a numeric representation, a vector representation of apples and oranges, we actually can compare apples and oranges because we've created and consolidated a single numeric representation that we can use to compare all sorts of things. And this is where you take this general idea and you apply it to data. So embeddings are a series of numbers. Vectors are a series of floating point numbers, an array of floating points. And they can be hundreds or thousands of dimensions. And a dimension is just an interesting feature or characteristic. Again, you think about interesting feature or characteristic of king or queen or data or book or whatever. And you just pick out those interesting features. You can calculate a numeric representation of those things, and you can create almost anything into an embedding. Audio, text, video, images, all sorts of modalities now. So you can now compare audio to video, or how is this piece of text similar to this image, or how is this similar to that? And again, looking at all these different modalities that we couldn't compare before, we now can do that using vectors. Okay, so we can take any sort of data that we have, we can create a numeric representation of that in order to consolidate it and now compare a lot of different things. But how do we search that? Because if you think about converting a database or multiple databases or all different kinds of corpuses of knowledge, or even just take every word in the English language, let alone every other language out there, and convert it down to a vector representation, trying to search that would be a nightmare, right? It would take hours and days to search all that information, all these vectors and long numbers. So those queries could get really expensive really fast. And of course, there's a good approach to this, and that is where you have the approximate nearest neighbor algorithm, or KANN. And the K just stands for any number. It could be 5 nearest neighbors, 50 nearest neighbors, 1,000 nearest neighbors, etc. And this makes it much, much faster. The example that I like to use is a library. Right now, you walk into a library and you have kind of general categories. You have nonfiction and fiction. Within those, you have genres. Within those, you have authors, and then titles, and then something else, maybe. But what if instead I walked into a library and said, I want to find all of the books that are set in or have an author based in St. Louis? Now, all of a sudden, you're picking out one particular feature that you're looking for, that you're interested in, and your result set is going to be much, much smaller. Instead of walking over to the science fiction section saying, what do I want to read this round? And picking up a book and reading the description and putting it back. No, I don't like that. And it's very trial and error and ad hoc. This, now I can do a search. It says, I care about this particular feature. Find me the books that connect to this feature. And it's going to pull out the relevant information that's most interesting to me. Much smaller search set, much faster retrieval time. Okay, so now we've created our data down to vectors. We can reasonably search it using similarity search or vector similarity search. Now we need some place to store that information, the vectors and the data and so on, to provide that to the LLM. There's lots of different retrieval source options out there. Many of you may be familiar with most of these. Vector database really has been around for much longer, but it really has hit the kind of major popularity segment, if you will, since this AI wave kind of went up and running. But of course, as with most markets, all the database vendors had to get involved, and so they started tacking on vector capabilities to their systems as well. So Relational jumped on board by adding vector capabilities and support to their databases. NoSQL, Graph, and so many others just started tacking on the vector similarity search capability to their databases. You could also, though, not just provide a database. It could be a directory, a website, and so on, or even just, a document or two that you could provide it as retrieval sources. The one we're going to talk about tonight and that I'm going to showcase is GraphRAG, which is where you provide a graph database as a data source for the retrieval piece. So you'll see we have a user. They're asking, or they're providing some sort of input, question, what have you. And then that's going to go to the application and do a retrieval against a graph database, which has vector capabilities as well, alongside a connected data structure, which we'll talk about in a second. And then it's going to pull that data back out, send that to the LLM, and then with the original prompt and the relevant documents, then that's going to go back through and send to the user the output of the LLM, its response for that. Okay, so before I go any further, does anybody have any questions so far? Because I know that's a lot. Yes. Yes, I will provide the slides after the meetup. Yep.
fact, you can even watch the video.
And I also post my slides usually on social, and I have a speaker deck account that I publish a PDF of it. So, I mean, however you want to access it, there's ways to do that. So, yeah, I don't know how to adjust that. Maybe if it's too close. Yes.
But the reasons to prefer Java for working with or developing with LLM?
That's a very good question. Yeah. So asking about if there were reasons to pick Java for working with LLMs over other languages. The thing that I found so far is that the bulk of your work and innovation is being done in Python. That's where all the like latest and greatest things are going on. The Java community is not quite as fast moving, I would say. So they don't necessarily have all the functionalities built in. I'll give you just one perfect example of this that I came across a couple of weeks ago. I was trying to play around with Pinecone, a vector database, and went out to their docs, and I was so excited. They have a Java SDK to work with their database. A lot of your vector databases don't even have a Java SDK, but Pinecone did. It was great. So I pulled it down, started working with it, playing around with it, and found out that a lot of the methods and their APIs endpoints did not support the Java SDK. It wasn't available in Java. You could do it in Python. You could do it in, I think, even Go, but you couldn't do it in Java. The Java SDK didn't support those endpoints. So it depends on what you're trying to do. If you're trying to do the latest bleeding edge stuff, Java may not support enough and do enough for you. If you're trying to implement it in your business, I don't know specifically that it really makes a huge difference.
I was guessing something like Kafka, which is written with Java first, might be a reason for working between those two. But
Yeah, I guess it kind of depends on what your systems are in too. So yeah, good question. I don't know that I have one specific, this is the language you should use kind of thing. It just kind of depends on what your existing systems are in and where you want to be in the AI space. If you want to be bleeding edge, I would recommend Python. Yes. Yeah. Yep. So the LLM, remember, is just a package, an endpoint, a tool that generates output based on an input. So it depends on the model you're using. You have embedding models that will create vector embeddings. You call the LLM, say, here's the piece of data, and it spits out a vector representation of that data. You have text models where you send it text and it will generate a text response for that input. You have image models, you have all sorts of other models. So an LLM really is just I put something in, I get something out, usually in natural language. There is no like knowledge or smarts about it, I guess. It's just, it's really good at, text models are really good at just giving you natural language responses for data. So instead of, I like to think of it as, if you want to serve up data to users or to business folks or to people who may not understand the internals of the system, you don't want to hand them a database record. They have no idea what that means. But you could take that database record, send it to an LLM and say, provide this information, and it would output it in natural language and make it understandable to just an average person. So that's why you see a lot of like chatbots. You see a lot of people generating emails and blog posts and other types of content because it's really easy to say, here are the inputs that I have, make something user understandable or human understandable out of that. The application layer is where right now you're handling and coordinating all those pieces. So you're having the application call the LLM, you're having the application serve the answer up to the user, you're having the application access other tools or knowledge stores or whatever, and consolidating all that information. Kind of like what we did beforehand, where it handles the business logic and the endpoints for, hey, I need this information, I need to assemble all these pieces, and then provide that back to the user. Is that what you were asking? Okay. Yes.
Follow up, I'm just looking at the data flow here.
Mm-hmm.
So the user gives a question to the application.
Yep.
It's going to retrieve all this information through GraphRAG, but then it feeds the prompt.
Yep.
Into the LLM. So it's doing some sort of a translation from a question into a prompt
Mm-hmm.
using the information in this knowledge graph or whatever. How's it do?
Well, I'll actually show that in the demo, but you basically, right now, it's not super sophisticated. And again, this is a lot of where it seems like a magic black box, but really what you're doing is you're creating a prompt of text. So basically a string, and then you're telling it, okay, I want to feed this extra bit of data and add that onto the string of text. And you're going to send basically that whole text block over to the LLM as input. And then it's going to spit out the answer or whatever it generates.
But the information that's being provided is somehow being learned by the LLM, or is it being used to query the
It's being used. Depends on what you're asking it to do. So in let's take a chatbot example. You're asking it, summarize this information or help me find, let's just take our demo example. Recommend books that I would like to read. It goes out to the graph, it pulls relevant information to what you're searching. It provides that up to the LLM, and the LLM takes that and said, oh, based on this information, I want to provide book recommendations. And then it generates text around the input you've provided it and the general task you want it to do, book recommendations in this case, and it'll spit back an answer. Here are some book recommendations I found for you.
Okay, so then in that case, the knowledge graph would be like a list of library books or something and their authors and their genre and all of that, which
Right.
is fed in
Right.
to the LLM. And then it's asked the question, what would I like?
Yeah.
So there's really two parts to this input. There's the data that it's going to base the response on, and then it's what are you wanting to do?
Right. Exactly. Yep. And then you had a question? Depends on the model you're using. So there are text models, there are image models, there are video models now. There's multimodal models, which will generate anything you ask it to, specifically. So it just, yeah. So you're sending it input and relevant data, and then it's generating stuff based off that. So whatever you tell it to input or generate something off of, that's what it'll hopefully send back to you without hallucinating. Yeah, did that answer your question? Okay, perfect. All right. Okay, so now we'll talk a little bit about why graph and what is graph. Now, I could give you a lovely definition and all of that good stuff, but I find it much more valuable to actually look at a use case and see how it actually works. So for instance, let's take these two people. We have Jennifer, we have Michael. And let's say we want to find out how they're connected, how they know one another, how they, something. We know there's a relationship there, we just don't know what it is. And let's say you find out, oh, actually these two people work for the same company. And so maybe there's dates, maybe they worked for the same company in the past, or maybe they currently work for the same company. You could have all that information added to that. But then you do a little bit more digging, you add some more data and you find out, oh, actually these two people attended the same school. And they also worked for the same company. Interesting. Okay, and now you might find out, okay, they were enrolled in 2 separate degrees. So they still went to the same school, ended up at the same company, but they actually have 2 separate backgrounds, if you will. And maybe, Jennifer knows somebody else that completed the same degree path and degree program there. So then you could fill in all the details, additional properties and metadata about that information. So particular companies, the school, the degree programs, and so on. Now, what a graph is, it helps you provide answers to questions through the relationships in the data. For instance, just based on this very small graph that I've done here, we could answer how many coworkers might have shared classes or degrees. So from a university's perspective or even a company's perspective, I could run these queries and ask this of my data. What are common degree journeys? So we have people that maybe go from one type of industry to another, or one type of degree program to another. Maybe you have a lot of people who switch degrees midway through, or they complete a degree and they go back for higher education. So how many alumni come back and actually re-enroll at our school for higher education degrees? They might start out with one degree, but how many people are new for the higher levels, or how many people are coming back? And then who else went to a school and works for that same company? You could run all of these types of queries with just this little bit of data that we have here. Now, the nodes, or if you're familiar with the mathematical term, graph term, that's vertices. These are your objects or your entities in the graph. So you can have labels, which kind of group or categorize your entities together. And you can also add properties, which are key value pair metadata, if you will, to kind of fill in some of the interesting information or the things you might want to store. And then the key part of a graph, which is the relationships or the edges, if you want to use the mathematical term, these connect the entities. You have to have a type or a label to kind of categorize or group the relationships, if you will. You must have a direction, at least when you store the relationship. And you can also add properties to relationships too. For instance, a person may have worked for a company, particular dates, or during a particular time. They might have enrolled in a particular degree program or certain classes during certain semesters or years, or et cetera. Might have had a particular teacher for that class, and so on. But graphs add context and meaning. It's not just saying these two things are connected. They're telling you how and why they are connected. For instance, these two people here, there's a lot of different types of relationships that could exist between Jennifer and Michael. They could be coffee buddies. They could go to the same coffee shop. They could attend the same conferences and so on. But no, this graph tells us this person is friends with this other person. Same thing, lots of different types of relationships between person and company, lots of different types of relationships between person and technology. Not only does somebody like this technology, maybe they work with that technology, maybe they submit GitHub pull requests for that technology, and so on, right? Now, GraphRAG is basically the same thing. It's just using graph as the retrieval source in retrieval augmented generation. And the benefits of doing GraphRAG over other types of databases or data stores for your retrieval augmented generation is it's going to provide a little bit better accuracy, that it provides the extra context through the relationships in the data. It also helps you verify that information a little bit better. Again, checking against something that's a very understandable data format. As an example, I have up here, you have a human view of an apple, which of course, many of us might have slightly different interpretations. Well, I like this kind of apple. I don't like this, fruit and so on. But if you look at the vector view of an apple, you'd have no idea if that numeric representation was an apple, or if it was a car, or if it was a building or a person. That data format is not human understandable, right? We can't just look at it and understand what it's trying to represent. On the flip side of that, now looking at a knowledge graph, this particular knowledge graph looks at kind of the biological data, if you will, or the plant data of the actual fruit of an apple. So it comes from a tree, it has a particular body and stem structure, it's a fruit, it has a size, shape, and color, and so on. But you could also put in your knowledge graph, for instance, the uses of an apple, or whether it's sweet or tart, or more mealy or something, or crisp, or the recipes that it's used in. This apple is good for apple crisp. This apple is good for just eating, and so on. You could store any of that information or all of it into a knowledge graph. Whatever you want to represent as important about that apple, you can represent in a knowledge graph. And that's going to make it really easy to verify when the LLM spits out its response and says, these are the recipes that are relevant to the apple. You can go back and look at, okay, here's how it got to these recipes from the apple. Here's the path that it traversed through the graph. I understand where this information is coming from. And again, explainability, being able to trace that path through the graph and finding out where it got this answer, how it got there. The benefits of GraphRAG. Okay. The demo that we're going to look at today, we're going to build a book recommendation system, as I alluded to a little bit earlier. And we're going to look at some search terms or topics that we can kind of ask of it. And instead of just going, usually when you do a traditional database search, you have the book descriptions and maybe a few tags, right? That you would do a lookup of a particular book or thing that you're interested in. Now that we have the vector embedding possibility, we're going to take user reviews, so reviews that somebody has written about a book, and we're going to create a vector representation of that text. And that's what we're going to search on. So I want to find books similar to this theme or this idea that I really like to read about. And it's going to do that search based on the reviews and find the related books for that information and serve us up some book recommendations. Okay, so instead of a lexical search or a keyword search, if you will, we're going to use a semantic search or this vector similarity search. And that's where the vectors come in, again, looking at those different features and how are these terms similar semantically rather than looking just for a particular keyword or a fuzzy search keyword. Okay. All right, so now we have data, representative vectors. We're going to run a similarity search in order to quickly search those vectors. We're going to store that data and the vector representation in a graph, and then we're going to serve that up to the LLM using retrieval augmented generation. Okay, so we're going to end up with an application that's going to do this. We have some kind of user input. In our case, it's going to be a search phrase that we want to find book recommendations for. It's going to provide that input to the LLM. The LLM is going to generate a vector representation of that input. It'll go against the database to search for things that are similar, semantically similar to that input. It'll retrieve the relevant documents, provide the original prompt and the relevant documents back to the LLM, and then the LLM is going to generate an output of book recommendations back to the user. That all makes sense. Clear as mud, maybe? Okay. So with that, I will add that nothing is quite a silver bullet. Remember, we're dealing with non-deterministic systems. It deals in probability, so you can't guarantee a completely 100% consistent answer every time. There are some different decisions when you choose different models. Some providers will work great for certain use cases and not so well for other use cases. It does take a little bit of prompt construction. You have to make some decisions about what you're asking the LLM to do and try to formulate that question in a good and helpful and meaningful way to the LLM, which sometimes that takes a little bit of detail. And then, of course, depends on the model you're using, but you could run up against some context window limits. That means it can only take so much information as input. So for instance, if I wanted to provide a 60-page document to a PhD student, that's one thing, but providing it to a 3-year-old probably isn't going to work. And LLMs are kind of that same way. They can only take in so much information. So depending on the LLM you're going to use, you have to kind of modify how much data you're sending it as input. All right, let's actually build stuff. This is the fun part. Okay, so we're going to go over to here first. And I'm going to build an application using Spring tonight, but there are lots of different options if you want to build a Java project or any other type of language project using AI. Spring AI is just one aspect of that. There's also like LangChain for J if you're doing with Java, and of course others in other languages. Okay, I'm going to stick with Maven. I'm going to stick with Java. The current stable version of Spring Boot. I'm going to just tweak this to categorize my app. And then I'm going to call this Gateway Jug Demo. And yeah, we'll stick with that. That's all good. Okay. And then it's a little too zoomed in. Okay, we're going to use the web dependency. It's going to allow us to create a REST API so that we can send it input and it will kind of interact with the LLM and the database, retrieve that and provide us output. And we're going to do that. And then the Spring AI supports a lot of different large language models. We're just going to go with OpenAI for tonight. But again, there's lots of options. So pick and choose what you like. And then I'm going to add Neo4j to that. So we want to provide it as a vector store. Now, Spring AI also supports a lot of different vector stores, Pinecone and a bunch of other vector databases, as well as I think it's PG Vector, which is Postgres with vector capabilities tacked on, Neo4j being one, and lots of others. So you can check out the full list. And then we're also going to provide it Spring Data Neo4j. Now, the one thing that is a little bit different about GraphRAG is that you'll do your vector similarity search, and then you have to run an additional query, a retrieval query, if you will, to go out and pull the related entities that are in the graph. So you do that vector similarity, pull the related documents, the relevant documents, if you will, in the vector space, and then you go out and pull the related entities to those entities in the graph. So it's kind of a two-pronged approach. So in order to run that retrieval query and map it back to our Java objects, we'll use the Spring Data Neo4j. And again, there's lots of databases that Spring supports too. Neo4j happens to be one. Okay, so with that, 1, 2, 3, 4, we should be good to go. I'm gonna drop that into downloads. Switch this over. Unzip that. Load this in. Okay. And hopefully that is all readable and good. While this is firing up, I am just going to check the POM to make sure we got everything in that we expected it to. So current version, stable version of Spring Boot. We have Java 17 as the current release. Now, I will note that Spring AI is not in GA use just yet. It's still sitting in beta, but they are up to milestone 6 release now. So hopefully it'll go GA at some point. We'll see if this year or not. But yeah, it is currently sitting in at milestone 6 release, and we have our Spring Data Neo4j. We have our web dependency. We have Neo4j as the vector store. We have OpenAI as our model of choice for this round, and then just kind of the other dependencies that get tossed in. Okay. So with that, everything looks good. And there are a couple of things. So I already have some database credentials set in my environment. So I don't have to add database credentials in my application. So it's externalized configuration. But there are a couple of things I actually need to add to the app. The first is to configure our Neo4j as a vector store. So I'm going to do that. I need to specify a particular index name. Yes. No, I'm running a Docker container with Neo4j running in it. And it's got the data already up and ready to go for me. You can still run embedded Neo4j, but it's not recommended usually because it's really easy to spin out your memory consumption there. And then last thing, let's see, Neo4j here. Initialize schema. There we go. True. Okay. Basically what this is going to do, so Spring AI works with a default type of an AI document, which is kind of their general object type, if you will, retrieval type. And because I have entities loaded into the database for books and reviews and authors and users, I am not storing documents at all. So I have to tell it, I have to customize that configuration and tell it, I need you to look for review entities. And this is the index, the vector similarity search index it's going to use to efficiently retrieve the vectors. And then this just basically says that if it can't find, specifically, if it cannot find a vector index that exists in the database, it'll go ahead and create one. Now, of course, you probably wouldn't want to do this in a production system because you wouldn't want it creating database indexes from your application. But just for demo's sake tonight, we're going to go with that. Okay. Now we can start creating our entities. So we're going to stick with some Java classes. I'm going to create records for tonight. So we have our books and then we have our reviews. So we have book and we have ID. We have a string book ID. We have a title. We have a ISBN, and we have, oops, if I could type, ISBN 13 that we're going to store all that. And we're going to come back to that in a second because we have to add the relationships. We got to create our other entity first. So here we're going to have our review. So we have a book review, string ID, and we have string the text that's actually somebody wrote about that book, and then the rating for that. Okay. All right, and then go back to our book, and now we need to wire these two things up. So we have a relationship, and it's a written for, I don't think I pointed this out on the data model, but a user writes a review and it's written for a book. So a review is written for a book. So we have a relationship type of written for. And then if you notice, I said a review is written for a book. So to the book entity, that relationship is coming into it. So I have to define that direction as an incoming relationship. And then we're just going to use list, review, and we're just going to call this reviews. That's fine. Okay, so that connects the two Java entities together. Okay, next is, let's go ahead and do our controller. So we're going to call this book controller. So this is our user facing, where we're going to have our endpoints that we can call and send the request. So we're going to create that as a REST controller. We're going to inject a couple of things. First of all, we need to be able to chat with the LLM, send information to the LLM, get a response back. So we have to use this chat client. Then we're also going to inject our Neo4j vector store. Vector, there we go. Call that vector store. And then it's wanting me to create a constructor. So yep, do that. And then I'm going to go ahead and, whoops, that is not what I wanted. So there's a couple of different pieces. IntelliJ and a lot of your coding tools now will have an autocomplete, and they'll also have like an AI assisted coding suggestion. And in IntelliJ, both of those things will pop up. If you hit the tab key, it's one of them. If you hit the enter key, it's the other one. And if you hit the wrong key, you get the opposite suggestion you wanted. And so then you have to go back and tweak and fix the code. So it depends if I hit the wrong key, and I'll have to go back and tweak some stuff. So keep me honest, make sure I don't make mistakes on that and mess something up. Okay, so the next piece is we need to actually have our endpoint. So we're going to call this /rag, and we're going to create our endpoint there. We're going to pass in a request parameter, but not a book ID. It's going to be a search phrase, because remember, we want to do book recommendations. We want to search a particular thing or theme or tag that we're interested in having book recommendations for. And then the first piece is going to be that vector similarity search. So we're going to go, remember that I said that Spring AI works with a document type or an object type of document. So it's going to retrieve documents from the similarity search, and then we'll have to convert it, which gets a little hairy here in just a minute. Okay, so we have our Neo4j vector store. We're going to do a similarity search. We're going to pass in a search request that we're going to add our query to, which we're passing in that search phrase as our query. So it'll do create the embedding for that input, that search phrase, and it'll call the database and try to find the most similar results for that and retrieve that back as a list of documents called results. Okay. All right. The next piece, which is where I'll switch gears, is where now we take those similar documents and we go out to the graph and pull the related books for that, right? Because remember, we have vector embeddings on review text. So we find the most similar reviews to whatever theme we're looking for, but reviews aren't really helpful for book recommendations, right? We have to go out and retrieve the related books for those reviews. So we're going to go out here and create a repository. So we'll call this book repository. And we're going to extend the Neo4j repository close, but our ID type is not a long, it's a string. And then we're going to provide that search query to go back to the database. So we're going to look for books. And those books are reviews, sorry, were written for those books. Written for, typing is hard, especially at the end of the day and when everybody's watching you. All right, and then where the review IDs are in a list of review IDs from those similar results from the vector search. And then we're going to return the books. And then we're going to collect all the related entities, so basically the related patterns, so that you don't get duplicates in this mix. So reviews. And then, it's pretty close. Let's fix this just a bit. I'm going to call this find books. And it's a list of strings that we're providing called review IDs as input. Okay. So with that in charge, we have our vector similarity search done. It's retrieving the most similar reviews for the thing that we want to look for. And then it goes out to the graph and it pulls the related books for those reviews. And then it's going to retrieve that back. So now let's plug that in over in our controller class here. So we're going to do a list books, not this though. We're going to do a, oh, I got to inject my repository. That's what I forgot here. So we need our book repository. Yep, injected. And yes, we want to add that as a constructor parameter. Okay, so now we're going to call book repository. Oh, not find all though. Got ahead of itself. We're going to do the find books. and we're going to pass in those results. Now, this is where it gets a little hairy, because what I'm going to do is I want to output each one of those books to the console so that we can see what's being fed to the LLM. But in order to do that, I like to print each book on a new line so that it's easier to read when you see the console output. So this is where it gets a little hairy. We're going to take the results. We're going to stream those. We're going to map each of the documents. Actually, wait. We're not doing that piece just yet. One second, sorry, I gotta back that up a bit. So this is where we're actually passing in the review IDs to query the graph. So I'm gonna take the results, I'm gonna grab, because I don't wanna send the whole document over, right? The whole review. I don't need that much information to run my database query. I really just need the ID of those reviews to look up the related books. So what I'm doing here is I'm taking each one, I'm mapping each of the document's IDs, and I'm collecting each of those IDs into a list to send as the review IDs list that I'm going to pass into that query, right? That's exactly what we did here, this review IDs. So it's just taking the IDs from the relevant documents, passing that into my database query so I can retrieve the related books. All right, and then now here is where I want to create my prompt. So I'm going to do a new prompt template, and I'll pass in a prompt here. Now, this is where I got to go back and add the prompt. So this is the question that was asked earlier. Actually, I'm going to do a string prompt on how do you do that and what does that look like? So nobody wants to see me write text. So I'm going to copy paste in a prompt here, and it's not really secret. I mean, there's no secret here, but it's just you're a book expert providing recommendations from high quality book information in the context section. Please summarize the books provided in the context. So this is where we're going to put in the related books that are coming from the database from Neo4j. And then I'm also passing in the original search phrase as well. So it can use that when it generates its response, okay? But now these are kind of variables that we have to fill in those gaps. So that's what I'm going to do right here. I have my prompt, and then I'm going to create a map. And I'm going to pass in, as the context piece, I'm going to pass in the books, dot, and this is where it gets hairy, because this is where I'm going to take each one of those books and output them onto a new line. So it's going to look a little bit ugly here. I'm going to do basically kind of the same thing that I did here. I'm mapping each book, and I'm going to do a toString here. And then, yeah, it got close, but it didn't quite make it. Collectors dot joining, yeah, and new line in between each one. So that's what it's doing there. It's just going to output it, make the console log look a little prettier when we go back to verify the data that's coming from the LLM. Okay. Oh, and I forgot. Needs, I think it's here. Yep, search phrase. So I need to pass in that original search phrase as the other piece, and that'll fill those gaps between the context here and the search phrase here. Okay. All right. So with that, now we actually need to call the LLM with that. Actually, before I do that, though, I want to actually print these, what's being sent over, so that we can see this in the console. So I want to log this out, basically. So template.render. So we're going to render the template, which is the prompt, plus the context and the search phrase data. So this is what is being sent the LLM. I'm going to output it to the console so that we can see it, so we can verify that information. And then we actually need to call the LLM itself. So we're going to call the chat client that we wired up above. We're going to call the prompt, call on the prompt. And then the actual object that comes back from the LLM is quite a long object with lots of key value, lots of extra metadata and information. We don't really need all that. We really just care about the answer, the text answer that's coming back from the LLM, or in this case, just the string, which is what this .content piece is. It's just retrieving that string answer back from the LLM object. Okay. And then I need to pass in my template, my actual prompt, template.create a message to the LLM. So prompt message. Okay. If I've wired everything up correctly, hopefully this will run. Let's find out. Okay. So here, zoom this up so we can see it a little bit better. And I called this Gateway JUG demo. Okay. I'm going to fire this up. Maven. Run. And I'll wait and make sure the Spring Boot app starts up okay. And then I'll flip to another window and we'll start asking it stuff. Okay, so far so good. Okay, so now we can start hitting our RAG endpoint. So we have port 8080/RAG. We're going to pass in a search phrase. And there's lots of different things we could search for in a book. Let's start with something super simple, though. Let's just look for things that have happy endings. And hopefully the first request usually takes a couple extra minutes because it has to connect all the pieces. Remember, we have our application. We've got an input coming from the user. That goes out to an LLM to create an embedding. It goes back to the database and then runs another database to run the query for the vector similarity search, sends that all to the LLM, which then generates a response back to the user. So it's kind of this round robin kind of looping thing. Okay, so I have a database of Neo4j book data sitting in Neo4j. Running in a Docker container. Here are the responses that it says for happy endings. So it has this first one. It says the story concludes with a happy ending. Reviewer who appreciated the conclusion features a happy ending here. Satisfying happy ending, which delighted a reviewer. Beautiful happy ending as reflected in the review. Overall, each book is noted for providing a happy ending. Okay, so let's go look at actually the data that got sent to the LLM and that's coming back from Neo4j. So here is the full prompt that's being passed to the LLM itself. So we can see the prompt. Let's see if this pointer works on the screen. Sure, it does. Okay, great. So we have this first one. Here's the book entity. And of course, it's much easier to see the books on each line. So titles, and then it passes the review ID as the connected entity. Happy ending is the text. Hurrah, we got that. Happy ending there. And happy ending didn't let me down. And beautiful happy ending. Now that's great, but I can do that with a keyword search, right? So let's do something a little bit more interesting. Let's look for something like encouragement. Let's see what we get out of that. And the data set I'm running on is actually an open source version of a Goodreads data set that was published a few years back. I just loaded a bunch of the books in. It's a huge data set, actually. Okay, so here are the ones we got. It's saying highlight theme of hope, faith, and the transformative power of love. Okay, and inspiring memoir. Okay, let's actually see what's coming back from the database, see where it's getting this. Okay, so we have encouraging, again, not super innovational there. Okay, what about inspirational? Now there's where the semantic search, this vector similarity search is coming in. A keyword would not find that. It wouldn't find inspirational unless maybe you provided a list of synonyms or something to look for. But inspiring and hope-filled, inspiring. So these are all synonyms, semantically similar to encouragement. And it's finding these things that are related because it's in that vector representation of these reviews. Okay, let's do another one. One that's a little bit more out there. And I like to do some kind of crazy off-the-wall searches just to kind of see what we get back. So the next one that I really like is to look for high-tech stuff. So high-tech books. It would be really hard to find that on a regular library search, right? Let's see what we get. I will note that by default, Spring AI will look for the 4 most similar results coming back from the database. You can set that to the top 10, the top 5, the top 50 if you want, but it's automatically default set to 4. So that's why you're seeing 4 results. Now notice though, this one comes back with 3. We'll check that out in a second. Since the narrative explores themes of perception and reality through a unique lens, mixed review, described as intelligent. Okay, high-tech, intelligent, maybe. Techno-thriller that delves into the implications of advanced technology on the human mind. And this one combines elements of thriller and mystery while engaging with profound questions about the impact of modern technology on traditional ways of life. Okay, that's kind of cool. So it's pulling stuff that's high-tech. Let's see what's actually coming back from the database. You can see intelligent, okay, maybe not quite what we're looking for, but again, semantic search there. The technology doesn't age well, which is kind of funny. But remember that we got 3 results back, and you can see there's only 3 books there. Why is that? Well, we have book, and you can see reviews. Good there. Book, you can see review. Notice there's a second review for the same book that's coming back as high tech. So it's retrieving 2 different reviews, But then when it actually does the graph query, it's saying, oh, we have 2 reviews actually for the same book. I'm going to consolidate that into 3 books. So you only get 3 recommendations as the output. So it helps consolidate that information. Yes, did you have a question? So I currently just have the reviews, and I do have book descriptions that I've created a separate vector index for, but I don't have the actual like book text, if you will. Yeah, you could put that in, absolutely. But that's a whole other topic about like text splitting and chunking and all that for retrieval. But yes, you can do that. People do that. Yeah. Yes. Yeah, so the thing that takes the longest is the initial connection. So it's kind of like when you run a database query, if it doesn't do a pre-warm up, it's kind of cold just to run the query in the planner. This kind of is the same thing. You have to call the LLM and like wait for it and get the request back. Once you do that once, it kind of warms it up, I guess, if you will. And the subsequent requests are usually a little bit quicker. So that would be if you incorporated like chat memory. So you can do that. I don't have it set. So it doesn't remember previous requests right now, the way I have it set up. But technically I could involve chat memory into my application, and it could remember previous requests and base its next responses off previous requests. But that's a whole other concept of like chat memory. And you can serve up parts of that chat or the whole chat into the context of your request each time. But of course, that runs against your context window limits too. You got to watch that. Good question, though. Okay. And then last but not least.
Books you could have fed in, say, the contents of the book.
Mm-hmm.
You'd be able to ask questions like, who are the main characters? What was the plot summary?
Yeah. Yep. Yeah, and it would pull back. There's actually some, in fact, Neo4j has done a couple of really cool applications where we took, like it's really hard sometimes to learn our graph data science library, which is where all the algorithms and kind of data sciencey stuff lives. And so they took our graph data science documentation, they took some really high quality blog posts, and they dumped that into a knowledge graph or graph database, Neo4j, and chunked it up into small segments of text. And then they put a chatbot on top of it. So people could ask questions like, how do I construct this algorithm? Or how do I write this algorithm for cipher 4 or cipher 5? Or how do what does this algorithm do? And it would pull up information on relevant documents. And then it would also save those interactions back to the database. So it would take the chat messages that are being sent, and it would also save the relationships between the documents that were referenced in the chat. So then you could start tracking, okay, where are people getting stuck? Do we have a lot of duplicate information and people are ending up in rabbit holes and don't understand this piece of text or don't understand this part of our documentation? And so then you can start improving the abilities of the chat and improve the LLM's responses and improve the documentation that's underlying that to really get a good idea of the performance and the helpfulness of it. Yeah. Yeah. Yeah, and then on like the internal side is understanding the help desk and where it's going wrong. Yeah, so like performance analysis and monitoring and stuff and maintenance. So yeah, lots of ideas and options there. Okay, one more that I will run that's a little bit even more out there just to kind of see, and you can combine, well, I guess I could run a couple of different things. How we're doing on time. Okay, great. So I've recently been really hyped on fantasy. I love science fiction books, but I'm really hyped on fantasy right now. So maybe I want to look for things like dragons and magic and see where these two things might coexist in books. Let's see what it retrieves. Okay, so it has a fantasy novel up here, so that's a good idea. Magic adventure and the challenges of her new role. Okay. Oh, this is Aragon in English. I've read that one. That's an awesome book. And I can verify that is dragons and magic together. Dragon Egg embarks on an epic adventure, encounters warriors, elves, magic, ultimately becoming a dragon rider. Okay. This one, loyalty and friendship, history where dragons are used in warfare. This one, Dragon riders play a crucial role. Yeah, magical. Oh, some found it lacking in magical elements. Okay, maybe not so much there. Okay, but let's actually look at the data that's coming back. So fun fantasy, lots of magic, beautiful adventure, warriors, magic, elves, dwarves, dragons. Okay, if you like dragons, read this book. Okay, long story short, it's a tale about riding dragons, the end. Okay, so that's the one that they weren't too keen on it. Maybe you can see the rating is too. So again, you can start adding filters and stuff for ratings or stuff like that. You can do kind of those keyword searches, if you will, and filter out some of the results if you wanted to refine that search to a little bit more relevance. But this is really just to kind of show the capabilities of that semantic search. The one more that I really love to run of this, because it pulls back some really wacky stuff, is caffeine. So we might want to find books that contain something about caffeine in them. I'm a big coffee drinker, so let's see. All right, delves into the themes of drug addiction. Okay, interesting. That's kind of odd. But remember, there's a lot of studies now that say caffeine is a mild form of drug, potentially. Okay, struggles. Okay, this is a really odd one. This doesn't even look relatively related to caffeine, so we need to go look at that. Narrative revolving themes of family and identity. Also, that one looks a little strange. Adventures of a detective's daughter, solving mysteries. Okay, where is it getting this data? Let's go look. Okay, so here's the information it brings back. So this first one, drugs. Remember, caffeine, mild form of drug potentially. So maybe that's kind of where it's getting it. This one I thought was really interesting. So at first I had no idea what C1, how that was even relevant, besides they start with the same letter. But then I did a little bit of research and was like, what's the caffeine molecule? And it's like C8H10 or something like that. So it may just be enough similar that that's how it pulled that semantic result there, which I thought was kind of fun. These last two I find kind of fun because they actually wrote the reviews on a blog, and you'll see that it's Fresh Coffee Blog, which again, semantically similar to caffeine. So just kind of interesting there. Again, it's not a keyword search. It's pulling just what's relevant and semantically similar, right? Which is kind of fun and interesting and sometimes a little hairy when you pull data.
In its answers, so I'm 90% confident that this is the answer to the question.
I mean, it's always going to be 100% confident. That's the problem. Yeah. Right. What people are actually doing in that aspect is they're feeding the answer into another LLM and having that LLM basically rate how valid or how helpful or how accurate that response is. And so, of course, that can get really expensive, of course, feeding every answer into another LLM in order to cross-check. But people are using other LLMs in order to evaluate first response LLM responses. So it kind of has to go through a series of checks. You could have a human verify it, you could have another LLM verify it, but that is one strategy for sure. Yes. I can't. I have no idea what it's going to respond with. What was that? Dragons. What was the full? And sorry? Oh, ISBN. Yeah, sorry. ISBN ends in 5. I don't think it's going to be that specific. Because again, it's pulling semantically similar. Positive characters, fantasy elements. It pulled Aragon again. Warriors, magic, elves, dwarves. Okay. So it only retrieved 2 things. Let's go over and look at what it got. Context. Oh, that ISBN is actually null. So that's not helpful at all. Okay, that second one here does not end in 5. So that would be a combination where you would feed it potentially like a pre-filter or post-filter, and you would have it do a keyword search or fuzzy search on that particular piece, and then you would have it do the vector similarity search. Yeah. The question was, what happens if you misspell a word in the prompt? That is a great question. It handles it really, really well, oddly enough. So let's just say I search Like, let's mix up the words a little bit more. Let's say, yeah, like that, maybe, or something. I've done this before. I've like mistyped encouragement or something. It handles it totally fine. Again, semantically similar. It's rough enough of an estimation. Oh, it did actually retrieve some different things. Interesting. Let's see what it pulled back in the data. Yeah, that was going to be a fluke. It's going to prove me wrong on this one. Okay, let's see. Oh, you actually do look though in this one, Planet with Dragons. So it did actually find it. That one, which it could be odd enough too, if somebody mistyped the review, it could also find some of that. Here's a novella dragonfly thingy. So it got close there. So again, yeah, there's that same one, beautiful adventure, warriors, magic, elves, dwarves, dragons. So it mostly pulled back, again, semantically similar with some slight variation, but yeah, it usually does pretty well on that stuff, again, because it's dealing with semantic searches. Yeah.
How much context does it have to dispel? For example, what do you type polish food because you forgot to capitalize it? Isn't that what you're trying to say? Polish food or?
Probably. That would be my guess. Because again, it's going to look for probabilities and the type, or how many times does Polish versus polish come before food? Polish is going to be a much higher relevance, much higher probability. So it'll accept that answer a lot better and pull data for that. I would have to run it on a food recommendation set, but that would be, if you ask ChatGPT, it probably would pull it fine. It usually is pretty forgiving. Okay. All good questions. Good stuff. Let's go back and wrap up with stuff though. And I'm happy to continue answering questions and hanging around afterward. Okay. All right. So first off, a couple of, I guess, kind of spiels, if you will. We are running at Neo4j a giveaway for a drone. This is for meetups. So if you want to enter the contest to win a Neo4j drone, feel free to scan the QR code there. I think last year, my community manager teased me because she's like, there was this person that won this drone out in the middle of the country in the US somewhere. I'm assuming that was probably one of your meetup people that are in attendance that won that. I'm like, yeah, probably, because I was at a meetup in Kansas City and I was at a meetup in a couple other different places, Chicago and so on in the central US, and nobody else at Neo4j covers the central US. So, so there's a decent chance of winning, I guess, for the drone. But yeah, that's kind of fun. We're running that right now. And then we do have, it just got released, dates for our online virtual free developer conference that's coming back. It's 7th year now. It's coming back in November. This is one of my favorite events every year. It's a lot of Neo4j content, but general graph, a lot of AI stuff going on right now, of course. And if you want to submit to be a speaker, or if you just want to attend, again, entirely free, all online. So you can join, in between your workday gaps or evening gaps or whatever. And it runs 24 hours of content. And all the videos get published afterward. So you have access to all the content and all the latest and greatest stuff. So this is a really cool event. I love this one. That'll be this November. And I guess the CFP is open now until the middle of June too. So if you're interested in submitting topics or ideas, feel free to check that out. Okay, and then everything for today. So these are the resources. All of the code that I wrote today is in that first repository link. It also provides links to like how I set up the data and resources for like documentation and different pieces. If you're interested in learning more about how Neo4j works with LLMs, like you want to know more about the nuts and bolts of the vector indexing and vector search, or if you want to write applications and so on, we have a series of online free and self-paced courses at Neo4j Graph Academy. We have a whole list of LLM courses right now. And then documentation for Spring AI. I've linked the Neo4j page here inside Spring AI. So Neo4j is a vector database, but again, lots of options for vector databases. And there's a whole list of models in that documentation as well. So you can look at the different large language models that it supports. And then I recently wrote a knowledge graph ebook. So it talks about how to get up and running with a knowledge graph and how to kind of do data import and query analysis and so on. So that is available. It's a free downloadable resource for you as well. So the QR code links to that too, but there's the full link for that. And if you have any questions, I will stick around. Thank you guys so much. Feel free to contact me later on down the road if you think of other questions too. But thank you guys for coming tonight.
Well, thank you very much. Do we have any questions here for our speaker or perhaps online, Ted? Or is anything coming in?
Yes.
Oh, we got a question in the back. Yes.
It came up earlier. What was where were you going to put the slides or the recording of this?
Okay.
Yes.
So if you go to the meetup page for this event, after it's over, as soon as I get the recording, I'll post a link to it in the comments section for this, and I can probably post the link for your speaker deck
Oh, yeah.
there as well. So the slides and the recording should be available there.
Yep.
Yeah, we're trying to work on a website, but we have some ways to go yet, but that'll get us going for now. Okay, anything else? All right, well, I think we can end the recording and we can move into the raffle part for those who are online. So if you're online, go ahead and stay online.